All right, everybody, welcome to our webinar today, Introduction to the HTC VIVE Eye Tracking SDK, and actually all the SDKs from HTC, but we're going to be focusing on that today. I'm Marcelo Lewin. I'm the program manager for the Deliver conference. I'm also the guy behind howtocreatevr.com, and our presenter today is Dario Laverde. Before we get started, I do want to remind you next week is our awesome Deliver conference, 3 days, starting on June 18th, Tuesday, full of training sessions. It's going to be hands-on, lots of things for you to take, lots of classes, lots of sessions. Dario will be there going in-depth into what he's covering today. So we're going to have over 20 sessions, 2-day hands-on workshops on Unity and 360 videos. So I hope to see you guys there. Register today if you haven't. Like I said, I'm Marcelo Lewin, the program manager for Deliver Conference. I'm also the guy behind howtocreatevr.com, which is the place to go after the Deliver conference. It's the place to go to learn more about how to create virtual reality. I have a lot of different presenters, podcasts, virtual reality events in Altspace VR, webinars, all sorts of things. So register for free at howtocreatevr.com, but do it after you registered at the Deliver conference. And instead of me speaking about Dario, I'm going to just have Dario tell us a little bit about yourself.
Sure, yes. So I have a degree in electrical engineering, but primarily for most of my professional career, I've been doing software development in all areas, back-end, mobile, embedded. So I've been at HTC for a little over 8 years now, and I was there when we transitioned into VR. It was a pretty exciting time. It's still exciting, getting more exciting. So primarily doing developer relations for HTC.
Now you're obviously going to present today on this great webinar, and you're going to be the presenter during your session. I think it's day 2, if I'm not incorrect.
That's correct.
Where you'll be presenting basically what we're talking about here today, but you're going to get more in depth there, right, on the SDK.
Yes, that'll be a more of a workshop format.
More of a workshop format where people will be coding or at least following you along.
Yes, exactly.
Yep, definitely. And if you do have any questions about this webinar or VR or anything like that, feel free to email me, Marcelo at howtocreatevr.com. If you have any questions about the Deliver conference, email Stephanie. She's the event manager. She'll get back to you right away. It's stephanies at fmctraining.com.
Thank you, Marcelo. I'm going to cover eye tracking with some live demos and live coding, but I'm going to also give you an overview. So basically, my agenda is really to give you an overview of all the SDKs we have available, singling out a few of the SDKs, and then leaving the eye tracking for the end and discussing what you can do there. I think there's relevance between these SDKs, and of course, you can actually use a mix of them in your projects. One of the things I want to start is to point out where you can get all the information about VIVE SDKs, and that's at developer.vive.com. Now we've been growing our number of SDKs recently, so when you go to that site, you'll see 3 categories of SDKs. On the left here, we have the VIVE Wave SDK. Now that's the SDK for our VIVE platform. Our VIVE platform is for the standalone all-in-one devices, specifically our VIVE Focus and our recently released VIVE Focus Plus, which adds the 6-stop controllers. But when you look at that platform, it also supports quite a number of our partners, OEM partners, mainly in Asia, but basically it's a platform that's a lot of different OEMs can use, and it's not just targeting one standalone. On the rightmost, we have the VivePort SDK category. VivePort is our distribution platform. So as most of these other storefronts, we need an SDK to support related functionality, such as in-app purchasing or for example, multiplayer support. But we're going to focus on VIVE Sense SDK, and that covers a lot of what are sense related, using the front-facing cameras, for example, using audio and so forth. When you go there, you'll see that we have a list of a number of SDKs under the VIVE Sense SDKs category. I'm going to single out just a few of these today due to lack of time. But we had back in March at GDC, we had a full VIVE developer sponsored day where we had all of our engineers, they all flew out from Taiwan to talk about each one of these SDKs in depth. So A lot of these slides are originated from those sessions, but if you want to actually really do a deep dive on each one of these SDKs, we have on our YouTube channel, the HTC VIVE YouTube channel, we have a number of those sessions available for you to view. So generally, we would like to start by explaining what XR is. This is it's just a semantic issue, but basically, I do like to point out that the virtual continuum, it really is going from reality into virtual reality. It's not really just AR versus VR. It's a lot of mixing of realities, and you'll have, for example, use of the front-facing cameras to detect depth and stereo, even when you're not using the pass-through for AR. You can use that information inside your VR world, or you can jump in between. And I'll show you this little demo, for example, where we're using the front-facing cameras, the Vive Pro, where you can mix reality and virtual reality and actually create a portal where you can actually cross over between the two worlds. And this is a great way for onboarding any VR experience, showing them reality and then having them transition into their world. That makes a big, profound impact. It makes it easy to get them familiar with the controllers, seeing themselves first, and then and you can see how you can actually interact between the two worlds and have it bounce back between the two worlds. So that's really exciting. That SDK's SR works. That's for the front-facing cameras, and we support Unity and Unreal. This is the architecture. It's very modular. Basically, it's three levels: the input, the functions that actually do the different functions, and I'll go over that quickly, and the output rendering to the display. So those three functions, three levels, and the function and the process that contains all these functions allows you to add additional capabilities. So, for example, we're going to add we've been adding AI, for example, in that. So it's very modular, and in fact, the reason I mentioned SR Works is that for the eye tracking, that SDK actually uses the functions here of SR Works. So we use this part of this framework. So again, apologies for going quickly through a lot of these slides. I think I have 90 plus. I'm just quickly going to do through an overview of what we have to offer, and then you'll understand why I mentioned this when we get into eye tracking. We also have the ability to scan a room. So this is, again, some overview of some of the features, see-through and how that works. We have the ability to do depth. And this is still a see-through feature, basically converting your fish eye lens to correct for, any of the required fixing of the lenses. Also, the distance between the two lenses can be fixed in software. And depth is the other feature of SR Works. And with depth, you can get real-time meshes. So you can actually have someone walk in front of you, and you can actually interact with a virtual ball. You can actually have it bounce off of someone in real time. So these are some of the factors that impact experiences, and we're always working on improving this. For example, occlusion is very important, as you've seen in a lot of AR experiences. If you want to be able to have it look real. So if a virtual object is behind you, you should occlude it. And depth, in this example, we're just mapping color to depth, but you can actually apply a depth map to do occlusions of your hands and so forth. Here's another example where you're slapping a fish, and you can interact, again, mixing virtual objects and have it being occluded, or have the virtual object go around the real object, as in that case. Here's an example of 3D scanning. And unlike the dynamic mesh, where you can do real-time, you can save this as an object that you can reuse, and you can have different levels of, here's the 3D reconstruction that I mentioned. You can have different levels of quality for scanning the room and using that as an object that you can save and reuse. And there's a lot of options for how you want that mesh to be processed and so forth. And here's just another example of interacting, of scanning your environment and then interacting with it. Throwing a ping pong ball and it'll bounce where you expect it to bounce and so forth. And then we added AI. So with AI, you can actually have it recognize a number of objects. In this case, you can actually have it recognize a table, a chair. Then you can isolate those, what you scanned, and reuse it as needed in your experience. For example, here you can actually select the chairs independently from the rest of what you scanned. So semantic segmentation, we can actually support 9 objects, and that's going to be growing. So those are the items you can actually detect now in real time. So this is a summary of the VIVE SRWorks SDK and its capabilities. I mentioned see-through, depth perception, and spatial mapping. And of course, we're going to, like I mentioned, we're going to improve some of these things. One example, let me just show you this little video, is having lighting be based on the surroundings of the environment that you're in. So that's one of the things on our roadmap for future improvements. At this point, I want to actually jump to something completely different. We have a Unity toolkit called a Vive Input Utility, VIU. I need to plug this because I think this is an important plugin that's a toolkit for any beginner or any pro to use to port between platforms. That's one of the main features. Basically, the ability to go from PC to standalone, which is a mobile device, and to do between different platforms, even our competitors. For example, it'll support the Oculus Quest. It'll support our upcoming Vive Cosmos. So, and that's usually done in Unity through the VIU settings. You can just target different platforms there. The next thing I want to talk about is hand tracking. This is something that is the next step to, I guess, removing the need to have controls all the time, depending on the application. And this is a separate SDK that actually supports, it's very lightweight, and it's just focused on hand tracking, and it supports the original Vive, which had a single camera, as well as supporting our standalone Vive Focus as well. So that's something new that we just released. Some of the features here is being able to detect predefined gestures, as well as a skeletal mode, where you can actually have all these points, or your fingers tracked, as you saw in that video. And generally, like I said, there's several platforms we support, and this is just explaining what features are supported in each. And this is getting improved. For example, for the focus, we will add the finger tracking, the skeleton mode soon. And here's some of the specs of the hand tracking. Obviously, it's not going to run at the rendering 90 frames per second, but it is significant enough so that it gives you a smooth playback, even though it's at a lower frame rate. And these are the game engines and platforms it supports. And here's just another example, a demo where you can actually use gestures to interact with objects. So for example, if you want to pick up an object, you can actually just do a gesture, pick it up, do another gesture to let it go, and so on. So this really opens up the power of having different UIs, not dependent just on controllers. You can actually use your hands, and of course, as you'll see shortly, you can actually use your eyes in combination. And here's just the same demo showing the actual person using it. And some of the simplicity of actually enabling this in Unity and Unreal. And recently we just updated this so you can actually map any hand model to that skeletal mode. Again, there's more APIs. Here's another example of an actual product we have in our Viveport where you can actually turn pages in the book with your hand. And some drawing. So you can imagine eventually doing a tilt brush type of a drawing app without controllers. And some of the features of the new release we just mentioned. And now on to Vive eye tracking. So as you know, we just launched the the Vive Pro I, not just in Europe, but also in the US, North America. You can currently download the SDK. We made that public. You can actually just go through. This is the outline of what I'm going to go through right now. So here are some of the requirements. On the left here, the software requirements, but more importantly is the hardware requirements. And this only applies to if you want to do foveated rendering. And if you don't know what foveated rendering is, basically it's the ability to have it where you're looking at, have the rendering be higher quality than around your where you're not looking. So in your periphery, it'll be lower resolution and so forth. And this really allows you to improve the quality of where you're looking at, so you can actually read things and you can actually make better use of your GPU, CPU. Right now, unfortunately, it's just supported with NVIDIA Turing architecture, so you'll need an RTX 20 series graphics card. Again, the downloads, if you go to developer.vive.com and just dig a little bit into the eye tracking SDK, which we call SRAnipal. It's related to SRWorks because it uses that framework. One thing I failed to mention about SRWorks and SRAnipal is that basically it uses the NVIDIA CUDA services. So a lot of those functions that I mentioned in that architecture, which is also used by the eye tracking, are mapped to service background services that are running on the GPU.
Does the Vive Focus support foveated rendering?
It supports a static foveated rendering. I should make the distinction.
Yeah.
Static is when it's always in the center. So your head will determine. It's kind of like gaze, where it's always in the center. With eye tracking, you actually can follow where the eyes are looking to do that. So it's more natural. When we partnered, just to clarify, when we partnered with Tobii for this release for the Vive Pro I, it was just much better quality to embed it into the headset rather than to have a third-party device that you just add on to it. That being said, there's nothing wrong with, we're working with third parties that are add-ons to different headsets, so you can actually get an eye tracking device that you put on the regular Vive or on the regular Vive Pro. It won't be the same quality because it's not integrated into it, but what we're looking at is we're forward thinking in that the SDK will support more than one type of eye tracking. And so you can just register an account at our site and just download what you need. The downloads actually consist of several parts. So you have the actual runtime to support the eye tracking that runs on your, in this case, Windows platform as a background service, in addition to having to download the actual SDKs. In this case, we have support for eye tracking and support for lip tracking. So this SDK supports lip tracking. That's a device that we showed off at GDC. It's an experimental device, so it's not really going to be a consumer device, but for researchers and developers who are interested, our SDK supports both. So the combination of eye and lip tracking really allows for full face tracking, and it really gives you a more immersive experience for modeling and so forth. We also have the foveated rendering as a separate SDK. So that is available on GitHub, but I believe it was just announced that it's also available on the Asset Store. So you can go to the Unity Asset Store to download the foveated rendering plugin for Unity. Now there's also another third-party Unity Runtime animation recorder. This is useful if you want to do mocap capture using eyes. So if you've seen a lot of the mocap, you'll see animators include some eye movement, but it's not as realistic as it could be. Of course, if you can actually motion capture the eyes as well, it really gives you an advantage, and it makes it really look more interesting that way, and more interactive, more immersive is what I want to say. So there's a runtime, like I mentioned, there's a separate install for the runtime to support eye tracking. And it'll become a tray. Maybe I can show that. On the tray here, you see my mouse, my arrow here. There's a little icon here. Anyway, this is what the icon looks like. It's our runtime. It'll show different colors. If you see the eyes light up, it means you have and in this case, I did have it with red eyes. It means I have the Pro Eye connected. If you see them turn green, it's because an application is actually using it. And likewise, this same icon is shared with lip tracking. So you'll see the mouth light up if you have that device and it's supported. But essentially, that device just hangs off the bottom of the Vive Pro eye, and you can actually it's just a camera facing the bottom half of your face. So it's more than just lip tracking. It's actually tracking the bottom half of your face from the nose down. And if you click on that icon, you get some more information as to what runtime you have, which version, and so forth. Calibration. I'm considering doing this live as a live demo of calibration, but let me just go through the slides first. So it's integrated as part, once you install the runtime, it's integrated as part of your dashboard, your SteamVR dashboard. So you'll see that option to calibrate, and you pick that, you'll see the screen, and once you hit calibrate, you'll go through this process. It's a 3-step process. And basically, it tells you whether the headset's on right, if it's too low or too high in your head, so they can track the eyes. Then the next step is it confirms whether your IPD is set. If it's way off, you can still use the knob that we use on the Vive Pro to adjust the IPD, but it tells you when it's correct because, of course, it's tracking your eyes. And then the third part is this dot that appears, and then it'll move around and tell you to just follow the dot with your eyes. And one thing I need to mention here is that you really need to do this calibration with your eyes, not your head. One of the things I found is, since we're also used to gaze tracking, so to speak, when you move your head around, people still have that habit of moving their whole head instead of just their eyes. And then once you're done with calibration, you can actually test it with this screen by looking at those dots there, and you can actually light them up as you look around. For foveated rendering, so I'm just going to step through the steps in Unity. So for example, as with any application that you're targeting OpenVR, in this case for the Vive, you need to install the OpenVR package for desktop. That's something that was added in recent Unity versions. We have a sample, both the regular plugin for the eye tracking and then the one for the foveated rendering have sample scenes. For foveated rendering, it's really just basically adding a script to your camera. And essentially, that's all you need to do actually to enable foveated rendering. Now, what foveated rendering this plugin uses is NVIDIA's variable rate shading, VRS. So it's really dependent on that. That's why we have that hardware requirement. But basically, when you install the plugin, just like any other plugin, you accept everything. And as I mentioned, we have samples, and it's really easy to get started. Now, for more advanced users, you may want to actually dig in a little bit, and we have all these options for adjusting the actual foveated area so that it uses a different pattern, different size of both the inner and middle and peripheral. So there's actually 3 areas. So all those options are available for you as well as for more advanced users. And going back to the recording, using that third-party package to record eye animations is pretty straightforward as well. These are the scripts used for that. And in this case, you would just add it to your avatar and then be able to record the eye tracking and then play back, which is really a really neat use case. I think a lot of people doing mocap are really excited about both the eye tracking and lip tracking. Yeah, and this is just some of the settings for the animation recorder. And here are some recordings being played back using that recorder, animation recorder. All right, so I'm going to now do some of the live demos. I'll start with the calibration of the eye. So now I have the headset on. Let me just share what I'm seeing. So of course, using the VR monitor for SteamVR, we go to display VR view, and you can see pretty much where I'm looking at. And now I'm going to call up the dashboard and select Vive Pro eye. You can see I already calibrated this, but I'm going to calibrate again. And again, this is just something you do once per user. So that's just something to keep in mind. This calibration is just per user. So I'm going to calibrate. See, I didn't have it right, so I adjusted it, and now it tells me it's okay. And IPD was okay, I already said it before, so it's going to say, yeah, that's okay. Now here comes the actual follow the dot calibration. So again, without moving my head, I'm using my eyes to follow this dot. It's just going to go to the four corners. And that's it. That's how easy calibration is. Once you're successful, so back in the dashboard, I can actually test it by looking at all these dots and lighting them up with my eyes. So you can see, I'm trying to light them all up in order. I can go counterclockwise as well. This is what is amazing once you wear this and you're able to do this without moving your head at all. Okay, so now we'll close that. So that was calibration. Next up, I'm going to actually launch a demo app. As you can see, it can track where I'm looking. I'm going to try to light these bulbs by just looking at the different bulbs around the mirror here. But of course, while you're wearing it, it's hard to see your own eyes because you're not looking at it. But hopefully you can see me look in different directions. You can see me try this with one eye or the other. So it can detect partial closing as well. It's fully open, as you can see there. So in this specific demo, I've got a handheld mirror as well. And actually, I can change some options here. So I'm going to actually start and change the avatar. So here's a different avatar. And again, I can move my eyes around. And again, the temptation is to move your head, but you don't have to. Here, you can use some anime-style avatars as well. And again, you can imagine for social VR, never mind just mocap, but for social VR, to see live rendering of your eyes. Seems to be a little jittery for this demo, but I think you can get the idea of how this can work in your applications and how. So I'm going to show you one more part of the demo. This is actually using UI. In this case, I'm looking at this button and selecting buttons based on where I'm looking. So I'm still looking around as well. So I can cancel this option to power down, or I can select the checkbox to exit the app. And there you go. So that shows you that you can do UI just with the eyes.
Quick question, because the avatar showed when you were closing your eyes.
Yes.
Does it actually track that? It's tracking
yes,
when
it's tracking. Wow. It's tracking how much you're closing your eyes. It's also one thing I failed to mention is that it tracks the size of the pupil, so you can actually get the emotional response from users. So that adds a whole nother dimension. And of course, there's a whole health industry that you can do. You can actually get eye exams. So that's where this is heading. Of course, you have to be a little careful in the privacy and collecting data. So we do have like a license agreement that makes sure that you're aware of the privacy of collecting data. For a lot of games, you won't need to collect any data, but for a lot of health-specific ones, you may need to. So it's just another issue that we want to raise for developers to be aware of.
Are there events that are triggered based on your eyes being closed? So for example, let's say I'm in the experience, I close my eyes and I can trigger someone that says, hey, wake up, don't fall asleep, or whatever, you know?
Yes, so you can detect how much is your eyes are closing. That's how we're seeing the model do that. So yes. So for Unity, here, it's a very basic one. In fact, I'm going to run it from within Unity. All right, so in this example, we're showing at different distances. At 1 meter, obviously I can select things a little easier. At 3 meters, it gets a little harder, but I think it's doable. And of course, at 5 meters, it's a little more difficult to select things that are close to each other. This is just one example of what developers have to keep in mind as far as selecting things at several different distances. So that's what this example is showing you. In this scene, we have the SRAnipal framework here. So it's just a matter of adding this to your scene. You don't really need to do anything else so far as the main camera is concerned. Here are the objects that are placed in front of us. But there is one other thing I want to point out. We have a gaze ray support, meaning you can actually show the where you're looking at using a ray. I'm going to enable this. I believe it's disabled by default. It enables a ray to be cast to where you're looking. So there's two things that we add as features. This gaze ray cast is one. The other one is the ability to detect which items you're looking at, and we're calling that focused feature, like where your focus is, which object. And all you need to do for the objects, you don't even have to add a script to the objects. It just uses colliders. So that's two features that you can start using out of the box. And obviously, all the other features I mentioned, so far as getting the size of the people and all that, that's part of the core APIs. But we want to get you started, so we added some more things, and over time we'll be adding more features.
Real quick question before you run that. On the gaze ray, is that customizable on the look and feel if you wanted to make it more fit your scene?
Definitely. So as you can see here in the inspector, we have a line renderer, so it's just a standard line renderer. You can add anything you want. You can make it look as fancy with particle systems or what have you. One example that I want to do is basically burn something or melt something with your eyes.
Right. Yeah, but you can customize it so it fits the experience.
Yes, definitely. And one of the things that we have happening here is also we have, when you close one eye, left eye or right eye, it'll show the raycast for each. But by default right now, when you have them both open, it's only showing one raycast from the center. So it tries to just show one, but you can actually change that if you need to. So let me just quickly show you that same demo with the ray. So now you can see where I'm looking at, and you can see what it is that I was trying to select. You couldn't really tell what I was trying to select before. So that's useful in showing you where you're looking at. And I've seen some apps use it, and most apps won't need to show this, but it's cool to be able to do that. And again, it's kind of averaging left and right, closing one eye and the other eye, and then when I have them both open, it's in the middle. Because it'll be more accurate that way as far as the intent. Like I said, you can modify the code so that you can show two rays, and then I guess if you cross your eyes, it'll cross the rays. I have yet to try that, but that should be possible.
But as Ghostbusters always says, never cross a rays.
Okay, so hopefully I gave you a very quick idea of what you can do in Unity with this. Of course, we support other platforms as well, but it's pretty easy to get started, and I hope everyone will give it a try.
There is another question. I've been asking you questions throughout that people have been asking, but another one is you just mentioned other platforms. Can this be used in, let's say, if somebody is doing Unreal?
But essentially, what I like to say is that most of our SDKs, not just eye tracking and the Foveated, but most of our other SDKs will also have a native SDK, C, C++. Technically, any developer, if we don't provide an Unreal plugin, technically any developer can use the native API and wrap it up if they want to provide blueprints for their developers.
And then do developers need to know, in this case, C# to fully utilize it?
I think so. Right now, you saw these simple examples. As we build bigger examples, there'll be less need to actually code. But for now, yeah, if you want to customize this, obviously you'll need to do a little bit of coding. But basically, it is drag and drop for these prefabs to drop into your scene and get up and running into your existing code.
And what are some examples of where you've seen already other customers use the eye tracking SDK for?
One of my favorite ones, it's a company called Ovation. The product is basically
Ovation VR, yeah.
Basically teaching you how to speak in public and rating you. And what it does is actually makes sure that you look around evenly to the audience and that you don't spend too much time looking at the teleprompter. And it'll take some analytics and it'll show you a point cloud later on of where you looked, or you can actually pinpoint which people you were looking at in the audience, and those people can actually react. So it can make it really, really interesting. That's a very good example. And in that, actually, it was that one that added the raycast. So there's a mode where you can actually see where you're looking at, which in that case is very useful.
Another question is, when do you see foveated rendering happening in most devices, not just the iPro? But at least I know you can only answer for HTC, but do you see this like 10 years from now, all devices having eye tracking, or do you see it sooner? What's your, we know this is an opinion because you're not talking about a roadmap, but in general, as an industry, what do you think?
I think once people start seeing the potential for this, especially in enterprise, everyone's going to be on it. It'll be one of those things like how do we live without this? As far as just another way of course getting analytics, again with the privacy issue in mind. But getting analytics, you can imagine, advertisers wanting to get all this analytics as far as
right.
You go to a store, what is that you look at? What's the best placement for products? Things like that.
You also mentioned the lip tracking and hand tracking. Are those available now for production, or are they still mainly experimental?
The lip tracking is mainly experimental. The hand tracking is available. The SDK will just add that to your application. It's nothing hardware specific other than having the cameras and the Vive Pro specifically. Yeah, so it's pretty exciting to combine these things, and that's why I did an overview of all these SDKs, because you can imagine having the pass-through cameras and using your eye tracking to interact with things, AR, MR, XR, however you want to call it, but it's really, really, really converging as far as the inputs.
Dario, I want to thank you for taking the time to do this. You did a fantastic job on the presentation. Thank you for showing us the examples. If people want to get a hold of you, do you want to give them your Twitter or anything?
It's virtual_Dario.
Thank you, Dario. Really, really appreciate it.
Thanks for having me.
Yeah, and thank you to everybody else. I really appreciate it. Remember to register today for the Deliver Conference, delivervrconference.com, and use How to Create VR to save $50. So again, if you have any questions, email me, Marcelo at howtocreatevr.com. So again, thank you everybody for attending. Dario, again, I look forward to meeting you in person over there in LA next week. And until the next one, and remember, register at howtocreatevr.com for free so you can get the on-demand version of this webinar, which will appear early next week. See you everybody at the Deliver Conference.